6 regular hexagonal blocks of side length 1 unit are arranged inside a regular hexagonal frame. Each block lies along an inside edge of the frame and is aligned with 2 other blocks as shown in the figure below. The distance from any corner of the frame to the nearest vertex of a block is 3/7 of a unit. What is the area of the region inside the frame not occupied by the blocks? So for this problem, you want to find the area of the entire frame, because if we can do this, then we can subtract the combined areas of the 6 smaller hexagons to obtain the desired answer. So we're going to need the fact that the area of a hexagon is equal to 6 times s squared root 3 over 4, where s is the side length. So how did I recall this formula? This is mainly due to the fact that the area of an equilateral triangle is s squared root 3 over 4, and a hexagon consists of 6 of these triangles put together. And of course we can simplify this as 3 s squared root 3 over 2. So if we can find the side length of the outer frame, then we're good to go. So in order to find the side length, we're going to draw a few different segments. So first, we'll consider this segment in black, connecting one of the vertices of one of the hexagons to the side length of the frame. And then since we have a bunch of parallel segments, we can now deduce that because the side length of the smaller hexagon is 1, as stated in the problem, then let's color code some segments. This red segment will also have length 1. Similarly, this red segment will also have length 1, as it is a side length. So we need to find this length is indicated in green. So the length of this green segment, because if we can find that, then we're good to go. Since we know that the remaining length is 3/7. So we just need to find the length of the green segment, and then we're good to go. So how can we do this? So one way we can find the desired length is we can look at this trapezoid. As indicated in black. So we're going to have this little trapezoid here. The green segment is what we want to compute. We know that the larger base is 1, as it is a side length of the smaller hexagon. And we also know that the top base of this little trapezoid has length 3/7, as it must be the same length as this upper segment with length 3/7. So the convenient part here is that every angle is going to be either 60 degrees or 120 degrees. So in order to find this green segment, we can consider a parallel green segment. So a green segment that is parallel to this side length, and then just chase a few lengths. So 3/7, 4/7. And now, because this triangle is equilateral, we can now deduce that the remaining segments of this trapezoid are going to be 4/7. So therefore, the length of the green segment is 4/7. So now we know the side length of this frame, which is 1 plus 4/7 plus 1 plus 3/7, which is equal to 3. So this outer frame has side length 3. Now we can find the desired area. So the area that is inside the frame, but outside the hexagons. This is equal to the area of a hexagon with side length 3 minus 6 times the area of a hexagon with side length 1. And so using our little formula, we obtain 3 times 3 squared times root 3 over 2 minus 6 times the area of a hexagon with side length 1, which is 3 times 1 squared times root 3 over 2. And we can do a little bit of simplification, so we get 27 root 3 over 2 minus 18 root 3 over 2. And this is equal to 9 root 3 over 2 is our answer. So the answer is C.